Okay, let's zoom into this next MCQ. Which element has the highest third ionization energy? Why don't you pause the video, see if you can work it out, draw out the structures, and see if you can work it out. All right, I'm going to go through the answer. So here we go. So lithium has an atomic number of 3, meaning 3 electrons. So we're 1s2, 2s2. I'm going to show the box orbitals because we're going to need to explain that. If you think about it slightly, we're taking the third electron. So really, we're going to remove that 2s1 and that 1s2 one, and then we're going to be left with just one before the nucleus. So pretty close to the nucleus, but no shielding. So going to be pretty high for lithium. Look at beryllium. With beryllium, we're breaking into a brand new energy level. So I reckon beryllium's is going to be even higher than lithium's because you're removing those first 2 electrons from the 2s2, which will be quite difficult because that is a full orbital, but then you're breaking into a brand new energy level. Now let's look at potassium. Potassium has 19 electrons, so we're going to go right up to 3s2, 3p, and we have 6. So the first ionization energy, 4s, sorry, 1, there we go, 19 electrons. We're going to remove one of those, and we're going to remove 2, well, we're going to remove one of the 3 P's, and then we're going to have to remove this one circled in red. But this is a partially filled 3P subshell, right? So at the end of the day, it's a partially filled subshell, so it's going to be easier to remove than breaking into beryllium, which is a whole new energy level and a filled subshell. Calcium. Let's check out the old calciomy. Calcium is going to be 4s2. So 3p6, 4s2. So we're going to remove both the 4s electrons. Now I'm trying to bus into another completely filled energy level, brand new energy level, and a totally filled subshell. So it's really between beryllium and we're looking at calcium. They're going to be the ones that have the highest third ionization energy. So if we look up at lithium, that's definitely not. That's going to be a relatively easy one to remove because it's a partially filled shell. Um, yeah, it's going to be difficult. It's close to the nucleus, but really beryllium's higher because we're looking at a full brand new energy level. We're breaking into the first quantum level, and it's a filled subshell. Again, for potassium, the third electron we're removing is from a partially filled subshell, a 3p5. And a calcium, we are breaking into a 3p6. So, and there is shielding. Right, there's no shielding for beryllium, so beryllium is going to be the hardest one to remove because it feels that nuclear attraction the most. It's very close to the nucleus. There's no shielding blocking it from the nucleus. Whereas, although the third electron in calcium is also in a totally filled subshell, so hard to break into, it is shielded from the nuclear attraction, so should be a lower ionization, third ionization energy than the one for beryllium. And there you go.